Hey guys, it's Joe again. I'm here. I'm going to teach you a little bit more with currents. So basically, I entitled this Dealing with Currents. Now, there's a lot of different ways to do this. As you can tell from this picture here, there isn't any voltages really given. Basically, we do know one thing. Everything is in parallel. We do have a current this way, we have a current this way, we have a current this way, and there is no defined current on the 8 ohm resistor. So we need to find that. Another thing we can tell is that this node right here is all in parallel. There's no resistors, meaning that whatever voltage is on the top here is the same voltage as here, is the same voltage as here, is the same voltage as here. And the only other thing I need to point out is that all the nodes in parallel, there is no current going this way or that way, and the reason is because if you think about it, these extra wires are just extensions to where the 8 ohm resistor is, or where the I/O over 4 or the 2 ohm resistor is, and we can redraw that, and I'll show you that here in a second. Okay, so basically the way that I think about this is I need to redraw it first. That's the very first thing. What do I know about this problem? Alright, well, we know that there's a 9 amp source going in some direction. We'll define it as this way, but it's going into, so it could be like the source current. And we have a 2 ohm resistor at some point, so basically the head of the 9 amps, so the head of the arrow touches the same point as the 2 ohm resistor, so that's 2 ohms, and that's I/O. And then that will be grounded if we define this as ground here. And then we have an I/O over 4, which goes away from the 9 amp. So basically we know that there is some sort of I/O over 4. And that's actually grounded up here, which we can't tell, but... And then the last one is the I/O over 4 actually touches the 8 ohm resistor. So we could say that's that node here. And we have 8 ohms. And that's grounded. Okay. Sloppy handwriting. Alright, so basically we have this relationship. Another way that we can think of it is we have 9 amps, and then you have I/O over 4 going out, and then you have I/O going this way, and then you have some sort of, we'll just call it IX, just whatever current going that way. We don't know what that current is. We have to find a relationship between the currents. So basically, if we define this as a positive number, the voltage at this point, and we're just assuming that it's a positive number, and this is the source, if we assume that's the source, usually current in a natural state will flow from the high voltage to a low voltage. So basically, if this purple dot is anything in the positive numbers, everything that's grounded represents 0. So let's say the purple is 2 volts. Basically, a current is going to want to flow in this direction naturally, or in this direction naturally. If you see a source as like this, that doesn't really necessarily mean that it's produced by the resistances. It really just means that the relationship, in this case, that the relationship of this current is I/O over 4. But it also means that it could be a source, like a current source from something else. I mean, who knows? It could be like a BJT, it could be like another electronic circuit or something that replaces this part. So that being said, there's multiple ways you can do this. You can find a relationship between I/O over the 2 ohm resistor and the relationship between VO over the 8 ohm resistor. Another way you could do this is something called a source transformation, which I can get into. A third way you can do this would be a current divider. So just like we had voltage dividers, there are also current dividers. And current dividers work a little differently as far as the ratio goes with the resistors as voltage dividers do. Now, what I'm going to do is go ahead and create a new page and show you the first way that I would do this, which is finding a relationship between your I/O over your 2 ohm resistor and your 8 ohm resistor. So earlier I had mentioned that this point, this point, this point, and this point is all the same voltage, and the reason why it's all the same voltage is because there aren't any resistors in the way. So like if there is a resistor here, for example, if there's a resistor here, the voltage here and here would be different. Well, there isn't, so basically it just means the voltages are exactly the same and they did not change. So with that being said, we know that if we label this something called VA, or if we label that something called VA, that the voltage here is the same as the voltage over here. It's the same exact. So what that means is that if we call this ground, there is a VA minus 0 over 2 would be equal to I/O. So that would be our first relationship. So if we had VA, which is the voltage above the 2 ohm resistor, and we divided it by 2 ohms, it's actually VA, the voltage difference, VA minus 0. So VA minus the 0 potential, which is the ground, divided by 2 ohms, should be equal to I/O. Okay, so basically the next thing I think of is, alright, well basically I/O is just a ratio of whatever the resistor is going to be. So what that means is if we say, okay, well there's a VA node here, it's exactly the same, and we do VA over 0, and then we do it over 8 ohms, that's also equal to some sort of IX, which we defined earlier. We said this was 9 amps, we said that's I/O over 4, we said this was I/O, and then we said, okay, well there's some sort of current, we don't know what it is, we don't have any information about it, we'll just call it IX. Alright, so basically what I'm getting at is if we have this relationship, we can say that VA, which we have, these VAs share the same similarity. So if we solve in terms of what VA is for this one, we can plug it into this one. So, okay, I/O times 2 I/O is equal to VA. And we can get that from this equation here. Alright, so now we have a VA here that we can plug this equation into. So basically what you're going to want to do is say VA is now 2I/O, so you say 2I/O over 8 is equal to IX. So basically, which is equal to I/O over 4. So basically IX is equal to I/O over 4, which is the same as that current actually. So with that being said, now you can do something really easy. We know that the currents flowing in, which is 9 amps, has to equal the currents that are flowing out. So if we say 9 is equal to I/O plus I/O over 4 plus I/O over 4. So basically now we have 9 is equal to 1 I/O, and then there's 2 quarters, so 1.5 I/O, so it's 3 halves I/O. And then we can say I/O is equal to 9 times 2 is 18 divided by 3, and I believe 6 goes into 18 3 times, so I/O is equal to 6 amps. So basically if we want to find out what the voltage is, VA, it's really easy now because we already have 2 equations that include VA, one of these two. Since this one deals with I/O as a whole and we already said it's 6 amps, you can say 2I/O is equal to VA, which we already found out, and that means 2 times 6 is equal to 12. Alright, so with these explanations, I didn't really mean for this video to really be 10 minutes, but I want to lead into the other ways you can do that, which is a source transformation or a current divider. In order for me to really show you guys how to do it on this problem, I really need to teach what that means. Maybe I'll show you how to do it on the problem first and then really just kind of go over what they are, kind of like I did with that voltage divider. It's going to be the same concept. So I want you guys to leave me some comments, any questions below, anything you guys have, please collaborate like I said, and I will talk to you guys later.